Okay, good morning. So in the last class, we have been discussing on some of the importance of processing in IoT, and we have seen very time critical cases as well as time critical and normal cases. Then we moved on to processing topologies. In processing topology, we have seen on-site and off-site topology. In off-site topology, we have seen another two. What are those? Remote sensing and remote processing as well as collaborative processing. So these were the classifications of processing topologies, on-site and off-site. In that off-site, we have remote processing as well as collaborative processing. We have also discussed on on-site processing. What do you mean by on-site processing? What we have understood in on-site processing? The processing takes place in the source. Yeah. So the processing of the data takes place in the source itself. So if it takes place in the source itself, we call it as on-site. So where suddenly there is a rising temperature, you can see an example. So that source itself, where the source is there itself the processing takes place, then it is called as on-site. Okay. So we have also seen that, for example, an application for healthcare or flight application, what we have seen, suddenly there is, for example, there is a fire detection. So the information is very critical that if you delay for a very minute second also, the fire will spread like anything. So you need to make sure that the information reaches to the destination, whether it may be a fire station or it may be police station or wherever it is. The information has to go very fast and make sure that the entire process is in control. So those cases, the latency, the bandwidth, all these parameters plays a major role in the data transmission. Okay. Now what is the next one? Offsite. The next one is offsite. So what is offsite? So what do you mean by offsite processing? So you can say that allows for latency. Allows for latency means what? What is latency? Delay in the network communication is latency. Delay in the network communication we call it as latency. That means when you send a packet, how much time it takes to reach to the destination, or what is the delay it takes. For example, now you post a letter in a post box. Then how much time it takes to reach to the address. Okay, so that is what it is called as the latency, and we have to make sure that for offsite processing, latency is not a major concern. Okay, so you can say that allows latency and cheaper than on-site processing topology. See, when something you need faster and something you need to make sure that it has to come in process, you have to make sure that all the equipments what you are using or whatever things whatever is concerned to that. If you, for example, if you want to increase the speed of transmission of information, you have to make sure that the technology is very much intact. But if there is no much concern about latency or there is no much concern about the transmission of data, it is okay that it takes its on time or it takes some delay, there is no issues. Then what you can say is the processing topology, what it will be slightly cheaper. Because you are not so much concerned about how you travel in a flight. You reach very fast. The cost of traveling is more. The manufacturing cost is more. But you travel the same distance in a car or a bus, you can see that the latency means the time you take to reach there, it will be slightly high. But you don't have that much urgency, so you don't go for higher cost, isn't it? So that is a very simple thing. Difference in cost is mainly due to the low demand. We don't have that much. See, if you are sending a photo or you are sending a video, if that much, if it is okay that it reaches some 1 minute later or 30 seconds later, it is not going to change any problem, then it is fine. So those cases you can say that mainly due to the low demand and requirement of processing, and you can say that the sensor nodes are not required to process the data on the urgent basis. Okay, so those things we call it as offsite processing. In offsite processing topology, the sensor node is responsible for the collection of and framing of data. And you can also say that few dedicated high processing enables devices which can borrow and multiple. So we have two different types in offsite. What are those? Remote processing as well as collaborative processing. So what we are going to, so by arranging the cost, so what it is there here, you can say that the cost will be comparatively less compared to that of on-site processing. Okay. So you can also say that the data from these nodes, sensor nodes, is transmitted either in the remote location or to a multiple processing nodes. So then see, when you are establishing some network, you have to make sure that the cost of the entire network is less. What is the reason? If you are going for a more cost, so you may not, you can just let us take an example that one node cost you almost 10 to 20,000 rupees. You will be deploying hundreds of nodes, so it will multiply by 100. So that is the problem. If the cost of that processing is less, so what will happen if it is like the cost of that one single node is comes under 5,000 and all. So you are reducing the entire network topological cost and the establishment cost, everything. So if you can establish more number of nodes, which will give you more precision and clarity. Okay. So all those things are there. So we have to multiple nodes can come together to share their processing power in order to have a collaborative processing of data. So we will be studying the other two methods, which comes in offsite processing, that is remote processing as well as collaborative processing. So you can just note down a few points, and we will move on to the remote processing as well as collaborative processing. I have in fact sent you these slides already. So what you understand by remote processing? What you may feel like? What is remote processing? Yeah, that is correct. You are going to do at a remote processing area where you don't have to do it where the real data is being taken off. Okay. So we'll see. So these are the things which we can understand. So let us go on further. So we will see the next one, that is two sub portions of that offset processing. First one is remote processing. So let us see what is remote processing. So what do you mean by remote processing? What do you understand by remote processing? Yeah, let us see that it composes of sensing data in various sensor nodes. So whatever the data it is taking from various sensor nodes, it is taking together, and the data is forwarded to a remote server or a cloud-based infrastructure. So you are going to take that whatever the data, for example, this node will give a data, this node will give data, this node will give all this data. We are going to collect it and we are going to forward it to a remote server or a cloud-based infrastructure for further processing. So whatever processing has to be done, it will be done not at the on-site process, it will be done off the site. So what you can say, it will be done in the remote server or a cloud-based infrastructure where this information will be processed and then it will be further transmitted. So that is what remote sensing you can see. Processing of data from hundreds and thousands of sensor nodes can be simultaneously uploaded in a single powerful computing platform. So what you understand from that? See, you have to process certain information and send it. Your node capacity has to be very high. But you are sending the information and then getting it processed by for example, you can say that you have a master and slave processor in computer. So you can say that these slaves are not doing any processing at all. They directly send all the information and the master computer will have high resolution and all those things. You might have heard about server and all those things, right? So the resolution of those servers will be very high. So what it is, the processing can be done very faster. The computing capacity will be very high. So you are not investing for each node. If you are investing for each node, the cost of production will be very high. Instead of investing for each node, you are investing for a single server. So what you are going to do, when you are investing for a single server, the processing, whatever it has to be done, it will be taken care by the server. If you are investing for single nodes, you have to, whatever cost is there, it will be there for every node, and it will come very high. See, one node you have to increase the computing capacity, all those things, it will be cost will be very high. But those are required whenever you are going for application like healthcare, you are going for applications like military applications, and you are going for applications like control. All those processes you need the computing capacity very high, and which you will be doing it for on the site process. But those things are not required when you take the case for an agriculture process or when you take some other process. If you are monitoring the water level, pH, and all those things in the sea, okay, you will deploy the sensors. You don't have to make sure that you have to process the data there itself. You can send the information to the cloud or you can send it to the server and you can get it processed there. So what is indirectly you are reducing the cost of each node. Is that clear for you? So that is what is happening here. Ensures the massive scalability of solution and significantly affects the cost of the deployment. So it will reduce the cost of deployment because you are computing power you are taking completely to the server. You are not making sure that your node computes the entire process, then it sends to that. It's clear for you. See, there will be now, for example, like this mobile phone is there. This you take it as a node. Okay, you have this has the capacity to compute all these things on the site itself and process it further. But instead of this, I am not investing so much. I am just collecting that. For example, I need a pH or I need some temperature. I am just doing that portion only and I am deploying. And whatever information is coming, it is coming to the server, and then further it is processed and done. So what is there? For this it is costing me 10,000 means for my nodes it may cost me 1,000, 2,000 rupees only. So what I am going to save my cost of production. So that is what, and further that information is taken to the cloud or for the server for computing and then for the transmission of information. So that is what this uses a lot of network bandwidth and heavily on the pressure of the network connectivity between the sensor node and remote infrastructure. So this is what. So this is one of the example. You can see the figure here. The sensing process, everything, and the remote processing is taking place in the cloud or a server. So that is the difference between on-site and off-site. Okay. So in the on-site, what you have to make sure, that each node has to be deployed. It should be high resolution, high capacity, high means it should be able to have the computing capacity, everything, so that it processes the data then and there itself. There is no delay. For on-site, the main concern is latency. or the delay should not be there between the transmission of information. But here the information is not that much important, so there can be some latency, some cost applications we can reduce the cost of production. Everything can be taken care in this case. Is that clear for you? So let us move on to the next one. What is that? Collaborative processing. What do you mean by collaborative processing? Together, isn't it? You are working together. You are collaboratively making sure that the processing cost, everything is done. For example, now you are having information, and you are using less computing capacity, but you have many servers connected to that. Many connections are there. It is collaboratively doing the process. So if you are taking some time, if everyone is there putting their hands together, but it will happen faster, isn't it? So that is the thing what it is happening in the collaborative processing also. We'll see that. Is that completed? Okay, you can complete it. So that's what we'll see the next one. That is collaborative processing. So what do you mean by collaborative processing? What you understood, we have studied on-site, off-site, remote processing, everything. So what is collaborative processing? Yeah. So you can see that used in the scenario where limited or no network connectivity, especially the systems lacking the backbone networks and all. So you can see here, this is the figure where you can see the collaborative network or mesh, where each sensor node collaborates with each other. One sensor node collaborates with another. Okay. So they together work together and they complete the task. So the topology is quite economical, and large scale deployment is you can see here. And so what is the simplest solution is to club together the processing power, and you can also say that it reduces the latency due to the transfer of data over the network. So even the latency is less. Okay, because you can see here, this is the node. This is one sensor node. This is another sensor node. So all the sensor nodes are interconnected to each other. They have a collaborative process, or you can say that it is a mesh. Okay. So if any information is received here, it will be transmitted to the neighboring nodes, and you can make sure that the data is being transmitted. It conserves whatever bandwidth in the network is there. That is one of the advantage, and you can say that reduces the latency of the transmission of data, as well as you can say that the quite beneficial, because what is the advantage? If applications like agriculture, all those things they can use where the data is generally logged after significantly long intervals. So we are not worried about the data being received at immediate basis and all when you are going with an application like agriculture and all. So you connect all the nodes connected together. Each node is interconnected to each other. So it forms a collaborative process. Like for example, if I take three mobile phones here this one is mobile phone. I tell them to connect through Bluetooth. Okay, so they are interconnected to each other. They can transmit any data. So, for example, I am deploying this kind of devices in the agriculture field. is a node kind of process where I can measure the whatever parameters I need. So they are communicating with each other. So they send the information, they receive the information. So what is that? They will be a collaborative process, and you can say that the implementation of this topology is very good for certain applications. So this is what it takes place. You can say conserves bandwidth and reduces the latency due to the transfer of data in the network. So these are some of the points to be. So this is all about the on-site and off-site process. So next topic is what? What is the next topic? IoT. Design. So this is clear for you. So what are the things we have studied till now? We have studied on-site and off-site. In off-site we have studied two. One is remote and collaborative processing. So what is remote processing? What is on-site processing? Which takes place at the source itself. What is on off-site? It takes place away from the source, or you can say that it takes place in the server or a cloud-based system. Okay. You have two classifications: remote and collaborative. What is remote? Processing. Yeah. So that is what you can say that the information whatever it takes from the sensor, it is being processed after the means you are not processing on the site, you are processing off the site. Okay. And collaborative means processing between different nodes. Yeah, the collaborative information sharing, that is, you can say that all the nodes are connected to each other as in the form of a mesh, and you can say that each transfer of information takes place. You can also say that the bandwidth is. So you can say the bandwidth conserves the bandwidth of the network as well as latency is also less. Okay. So that is all about these concepts. And what is the next one? So IoT device design and selection consideration. So this is very important. Now, so IoT device design and selection consideration. So for example, I told you to do a mini project. So when I told you to do a mini project, you have not gone to market and selected whatever components you want, right? You have gone to the market, you have selected the components which the project it needs. You have not gone and simply randomly taken some of the products and some of the things, and you cannot do it. So you went and selected the appropriate product, isn't it? You didn't go randomly and selected few things and you came. Is that the thing? No. So similarly, when you are going for the design, it is very important to know that what is the size, what is the energy consumption, what are the parameters you are going to define. And it is you have to make sure that your node is capable to withstand the power consumption. Size should not be so bulky, it should be small. All those things you have to make sure. So we are going to study in this topic how the IoT device design has to be taken care, and how the selection of the process to be done. What are the main things you have to consider? So what is that? So IoT solution, so selection of processor. You know that when you are selecting, let us take a simple example of a mobile phone itself. If you are buying a mobile phone, what are things configurations you see? What are things you see? Louder. Yeah. You can say louder.
Memory space.
So when you are selecting a mobile phone itself, you will see the memory space, camera capacity, battery backup, graphics card, graphics card, yeah. Okay, then what else? Processing speed. Processing speed. Which processor it has used? You will check, isn't it? Then it's refresh rate. It's then design. Its color. You will finally always see that how good it looks like, and you will also see that what is the size, whether it is too heavy or it is compatible to be carried. You will see all these things now. You see all these things for a node, then your work is done. You see all these things when you are designing an IoT node. The same thing, same thing. You need to see the size. See what all things we are going to see here. You need to see the same way. You need to see the size. Then what you need to see? You need to see the energy. You will see the cost. You will see the memory capacity. You will see the processing power. You will see then further the IO rating. Then you will also see the add-ons. So all these things, if you see, you can say that you can design a IoT node. Is it easy for you to remember? So if you go to the market to select a mobile phone, what are the features you are going to see? The same features you have to see for the IoT design as well. So let us see the first one, size. So selection is very important parameter when you are considering any IoT devices, because if you are not seeing the processing capacity and all those things based on your application, you may feel that you will not be able to run that application. For example, you are doing it for some military application. You need high processing speed. So you are using some Arduino and all those kind of things which will not process at all. It is not going to make sure that your project is going to move further. So it is very important for you to use the high-end processors. Means low size, less size, high energy means it should be capable to withstand for a longer duration. Energy consumption is very important. So all those parameters you have to take care. So let us see the first one, the size. First one is size. So it is a critical factor in designing the any setup or any IoT device. It is very important to make sure that the size is not too high, means too big. It should be small in size. But you cannot see, for example, if you are having a mobile phone also, if they reduce the size this much, that is also not good, isn't it? So you need a specific size, a compacted, optimized size, which will be useful for you to do the processing. Okay. Larger the form factor, the energy consumption it will affect. The see, you go for high display, all those things, whatever you go for, isn't it? When it is HD plus, all those things you go, what will happen? It will consume your energy faster, or your battery capacity will drain out faster. So all those things you have to make sure that it should be able to withstand certain duration of time. All those things are very important. So large form factors, yeah, and bulk IoT applications, you can say that you will go for some of the applications you might have seen. You have a wrist watch, no? Where it measures the heartbeat, pressure, pH. I don't know, before I know people were living without all these things, but nowadays it has become a fashion. Okay. So, simply you will see whether your heart is beating or not. So that kind of doubt it has created. So some of you will have footsteps and all. Even though you are walking maybe hardly 1,000 steps, you make sure that move your hand and make it somewhere around 500 steps extra. So you can, because it doesn't know anything, no, it doesn't know whether you are walking or you are. If you move your hand also, it will think that it is walking. Okay. So that is what, correct? No? You did observe. You did observe. So there are many IoT applications where now we will go with the size. So you know that size is a very important parameter with respect to any application. So we'll see the next parameter. Is that done? What is the next parameter? Energy. Why energy is very important? There are a lot of research articles on how to conserve the energy of can be used in order to improve the performance of the network. See, if you are how the you can see that whenever you use the mobile phone and all, how the energy drains out faster. Not only what you use, it also depends on how you know to use it or not. So some of the cases the energy drains faster because you use unnecessary applications which is not required for that to be done. Some of the things will be running back or back the screen. Isn't it? So all those parameters we have to take care. So energy requirement is a very important parameter. Most important deciding factor for any IoT network. Because if you don't have energy, your node will fail. Your node will fail, your network will fail. So it is very important to have the higher the energy requirement, the energy sources like battery replacement, frequent. If you have deployed the nodes at very remote places and all, you cannot go daily basis and change the battery and come. Is it possible? Or you cannot go on daily basis and keep the node for charging. So if you deploy a node at a remote place, at least 6 months to 1 year, it has to run. So that is what you will be expecting. So you have to make sure that automatically lowers the load term susceptibility, and so it is very important to have a good infrastructure, means good node setup where the battery backup can be for little longer duration. Then cost is no need to explain much about the cost. You know that you are very much concerned about the cost. The higher the technological advancements you inculcate in the network, or you make sure that more the technological advancements, recent advancements, the cost will automatically be higher. So you have to make sure that you have to go for the optimum requirement, which is going to serve for your particular application. For example, you are doing a certain application and you don't have to go for a very high end nodes and all. If your application is very much precise to a certain things, you can select your devices in such a way that you can optimize the cost. See, cost optimization is also very important parameter in any project. So you can say that cost of a processor, cost of a sensor, all these things, density of the number of nodes to be deployed, all those things is very important for you to calculate. Cheaper the cost, the hardware enables higher the density of hardware deployment. Means what? If you have one node cost you 5,000, same node you are manufacturing the same node for the same capacity for some 10,000, you will be not able to deploy more number of nodes. Your cost will be doubled. So you have to make sure that entire cost plays a major role in any project development. Okay. Example: cheaper gas and fire detection solutions are enclosed in. This is very important for any. So these are some of the parameters. Still, we have a few more parameters. What are those? Memory and processing power. What is memory? So memory means what? Memory requirement for the IoT, it is volatile and non-volatile memory. Then you can say that low data processing, data storage, data filtering, data formatting, all these things take place. You say no. You say that you need this much of memory, 256, or you say that 1 MB, or you say that see, when you are going for a node, you cannot have 1 GB and all. So your memory capacity will be less. So, but optimum how much is required, that much will be for the processing to happen. What are the processing it has to take place, all those things based on that, the memory capacity can be set. So device with high memory tends to be costlier. So it is no problem that you can enhance the memory capacity. But if you don't need so much of memory and you are putting so much of memory into the node, what will happen? The cost will increase. So you don't want your cost to go high. So you need to make sure that your memory, everything, whatever is required, you need to optimize it. So that is very important. Processing power means what? The speed of processing, that is what type of sensor can be accommodated to the IoT node, what is the processing features, and decides the type of application which you are going for, and applications like handling videos, images and all these, you need more processing capacity. And some of the applications like which is to be done faster, like the applications in the military applications or some of the applications where the processing speed has to be very high, those cases you need to go for a good processor. So selecting a good processor with high speed and all those things, you have to select based on your application, not simply randomly whatever it comes. Okay. In market, all the things will be available. But based on your application, you need to make sure that your design process has to come. So this is what the higher the processing power, and which will be very much important. What is IO rating? So IO rating we will do it in the next class. Okay, we will wind up here. Thank you. Only IO rating is left out and add-ons are there. We will do it in the next class then. So these are some of the parameters which determines the the functionality of the node and the optimization of the node.